All right, so to review, hopefully you guys learned in your previous class, chemistry classes, that this is kind of what an atom looks like. In the middle, you got a nucleus. The nucleus is made out of protons and neutrons. So the nucleus has a positive charge. So we're talking about electrical charge, electrical energy. The middle of the atom is positive, and the negative ones, the electrons, fly around the nucleus. Do you have everyone remember that from your previous chem classes? Okay, everybody except for the people in my class. Sorry, guys, I let you down. Just kidding. Okay, so that's going to be what an atom looks like. So the protons, neutrons, and electrons, they determine different things about the atom. So changes to atom's characteristics. The protons, it tells you what element the atom is. Okay, so I'm talking about the stuff on the periodic table. The protons determine which element the atom is. The neutrons, depending on how many there are, it determines the isotope. So that's like the version of the element, okay? And then the last one, electron, tell you the atomic charge. Okay, so what electrical energy the entire atom has, okay? All right, so let's start with the protons. So the number of protons something has is called the atomic number, okay? And the atomic number is gonna be the number on top of the box on the periodic table. So if you have a periodic table, and you don't need one right now, so don't feel pressure to pull one out. But if you got a periodic table like this, every single box has a number on top, right? Those are called the atomic number. And that also tells you how many protons that atom has. So hydrogen has 1, lithium has 3, beryllium has 4, so on and so forth. Okay. Now, that's going to be the atomic number. And a lot of times on the AP test, they might denote the element like this. So they put the symbol right here. And on the bottom left, they put the atomic number. So if you guys take a look at carbon, carbon on the periodic table should look like this. C, and then there's a 6. Since carbon has 6 protons, they put the protons right here on the bottom left. Okay, so if you ever see a symbol like that, the number on the bottom left just means the number of protons, okay? So for example, if you got helium, you might have a 2 like that. If you have lithium, you might have a 3 on the bottom left. All right, so far so good? All right, so the number on the top left right here, this is going to tell you what's called the mass number. And the mass number is, we calculate that by adding the protons plus the neutrons. So if you might want to write that down. You'll have to memorize that formula, unfortunately. But the mass number on the top left is going to be the protons plus the neutrons. And this is going to determine what isotope the element is, okay? So isotopes are different versions of the same element. So there's different versions of oxygen, different versions of hydrogen, and those are called isotopes. Okay, so we are going to do a couple problems together, or 2 problems together, just to kind of get you guys familiar with how to calculate isotopes. So let's try this right here. Okay, so 2.1. We're going to be taking a look at how many protons, neutrons, and electrons are inside of, this might be hard to see, but it's Hg 197. So I'll write it kind of big right here, 197 Hg. So I want you guys to take about a minute, see if you guys can work with the person next to you and calculate the protons, neutrons, and electrons for this, okay? Okay, so for Hg, first thing you want to do is just take a look at the periodic table. If you guys need a periodic table, I got a bunch up here. You guys can take one. That'll be my only gift to you the entire year. But if you take a look at Hg, Hg is right here, kind of in the middle bottom. Okay, Hg is mercury. And how many protons does mercury have? 80, yeah. Okay, so mercury has 80 protons. We're going to write 80 for the protons. Okay, for the neutrons, we said that this number right here is the protons plus the neutrons. Okay, so we know that there are 80 protons. So in order to find the neutrons, super easy, you just need to subtract. So we're going to subtract 197 and 80. So 197 minus 80. And if you do it in your head, that's fine too. And so that's going to give us 117 neutrons. Okay. So far, so good. And then lastly, for the electrons, if you notice, there's nothing up here. This right here tells you the charge. We didn't really talk about that yet, but hopefully you learned that in your other classes. And if there's nothing here, that means the charge is neutral. It's 0. And so if there's nothing here, that means you have the same number of electrons as you do protons. Okay, and that's it. All right, any questions about that? Let's move on to 2.2. So I'm going to teach you 3 different ways to write the name of the isotope. It's kind of annoying, but there's 3 different ways you'll have to be able to identify the isotope symbols, okay? So first of all, it tells you that the atom is neutral, so we don't need to worry about electrons. Okay, so we got 92 protons and 143 neutrons, okay? So let's look for the atom that has 92 protons. So periodic table, we go down to the very bottom, and we got 92, which is uranium, okay? So uranium is going to be the one that has 92 protons. So we're going to write U. And then in order to find the mass number, we're just going to add the protons and the neutrons. So 92 plus 143, that's going to give you 235. So the first way you can write the symbol for this atom is like this. Just 235 on the top left and then U. Yes. Yeah, so we're going to guess that. That is one of them. Okay. The second way is super easy. It's the same thing. Okay. The only difference is we just put the proton number underneath the isotope number. So this is the first way. This is the second way. Alrighty, and then the last way, you just write the full name. So uranium, it's named after my favorite planet, and then it's dash 235. Okay, so that's the third way. So you might encounter the name of this atom 3 different ways. All 3 of them kind of communicate the same information, just in a different form. Okay, so if you ever see any of these 3 notations, you'll understand what you're looking at. You got uranium, which has 92 protons, 143 neutrons. Right? Any question on any of these? AP test might give you any of those 3. Okay, so let's move on to the next section. So we took a look at the number on the top of the box for the periodic table, right? We took a look at the number of protons. Now we're going to take a look at the number on the very bottom. Okay, now this number on the very bottom has different names, but I'm going to tell you guys like the most accurate way to describe it. Some of you guys probably have heard it as like molar mass, right? That's the way I'm more comfortable using it too. But if you want to get super technical, it's called the atomic weight, okay? And the atomic weight, the description is right here. It's the average atomic mass of each element based on their relative abundance. So what does that mean? It means when you go into nature, and so let's take a look at this one right here, potassium. And if you find all the potassiums, right, they all kind of have a different weight depending on how many neutrons there are. And depending on what the average, we take a look at the average. So some of them might be heavier than others. Some of them might be lighter. But what we do is we take all of them and then we find the average. And that's the number on the bottom of the box. Okay. So for example, we got one for carbon. 98.9% of carbon is carbon-12. So most carbons, 98% of them, basically 99% of them, they're going to have 6 protons and 6 neutrons. Okay, and only 1% are carbon-13, which is when they have 6 protons and 7 neutrons. Okay, and so we use that information to calculate. AMU is a way, it's called atomic mass unit. It's the way that we measure atomic weight. We use that information to calculate that carbon has an average mass of 12.01. Okay. So I'm going to teach you guys how to do that calculation in just a second. But that's how we find the atomic weight. Okay. We just take what percentage of each element weighs that much, and then we just average it out together. Okay. Okay. So let's do a problem together. And then I'll have you guys try one on your own, and then we'll go over the last thing for today, and we'll be all done. Okay, so let's go over 2.3. So it gives you the percentages, the relative abundance of the two isotopes of chlorine. So the first isotope we have is chlorine 35, and 75.78% of chlorines is chlorine 35. And then the remainder, 24.22% of chlorines are chlorine 37. And again, the difference is how many neutrons there are. Chlorine has 17 protons, and you guys don't need to write this part down. This is just kind of for your reference. Every single chlorine has 17 protons. It's just that this guy right here is going to have 18 neutrons, which makes it a little bit lighter. And this guy has 20 neutrons, which makes this guy a little bit heavier. Okay, so that's the difference between these two isotopes. Okay. But you don't need that information to do the math for this. Okay. But does that make sense why they weigh differently? It's just there's extra things inside the middle. Okay, so let's calculate the atomic weight of chlorine. So first thing that you want to do is you want to turn the percents into decimals. Okay, so turning percents into decimals is really, really easy. You just move the decimal 2 times to the left. So 75.78, you just move the decimal twice to the left. So you'll get the value 0.7578. Okay. And then you just multiply it by the atomic mass, or the mass number for that isotope. So this one is 35. So we'll do 35. And then we're going to add that to the same thing of the other one. So 24.22 is 0.2422. And this is going to be 37 AMU. That's it. You calculate that, and that'll give you the atomic weight, the average weight of chlorine. Okay. So it's a lot of just basic algebra in this class. It's got to be very fluent in doing algebra. Okay, so I'll give you guys a second to punch that into your calculator. See if you guys can get the atomic weight of chlorine. And if you finish that early, you can start 2.4 right on your own. Okay. All right, so up here, I already wrote down the way that you should set it up. So 92.23% of silicon 28. So we got 0.9223 times 28 AMU. And the other isotope, silicon 29, is 4.68. So here, just make sure that you're careful. Move the decimal 2 times to the left. So you get 0.0468. I know sometimes if you're rushing, you might write 0.468. 4% is going to be 0.04. And then lastly, the 3% is going to be 0.0309. And then just plug and chug into your calculator, and you should get a final answer of 28.10, about 9 AMU. Okay, something around there. Okay. Yes. AMU. Atomic mass unit. All right. Any questions on the setup for that? All right, so we're going to finish off talking about isotopes. A lot of times on the AP test, there will be questions on this thing called mass spectrometry. Okay, you can call it mass spec. Sorry, before I move on, anyone still need this? Again, if you miss any part of it, it is recorded, so you'll have all of this on Canvas. Okay, but a lot of times they're gonna ask about a question called mass spec. Okay, now you guys don't need to know this super detailed, but mass spec is basically just a way in laboratories in real life. It's basically how people find out just how much. Okay, so how much of each isotope there is. Okay. So it's just a way of finding out how much of an isotope there is in a given sample. So let's say that since we're looking at one for selenium, let's just say that I have this, I don't know, this tube of selenium, and I want to figure out, hey, what are the isotopes in there? Okay, so what I would do is I would put it into this machine called the mass spec. And what the mass spec does is it vaporizes whatever sample you have. So it turns it into gas. And then once it turns into gas, it shoots it basically through, you can almost think of it as like a atomic scale. And then based on how heavy the isotopes are, it'll separate them. And then it'll produce this graph telling you how much of each isotope there is. Okay, but you don't need to know that process super well. Just know mass spec means we're looking at how much of each isotope there is. Okay, yeah.
If you separate them using separable force, like
No, they're too small. Yeah, you would need too much. Yeah. All right, so mass specs look like this. Okay, now I know this might look a little complicated, but I'm going to break it down super simple for you guys. Okay, the bottom right here is going to be the mass number. Okay, so if you take a look at this, okay, this column, it says 74, right? So this bar right here is going to tell you how much percentage there is of selenium 74. Okay, this bar right here tells you the percentage of selenium 76, 77, 78, 80. You guys get the point from there, right? And then obviously the height of the bars tells you the percentage. So if you take a look at this, let's start with, I'm actually going to answer 2.5. You guys might not see it, but 2.5 is just basically asking how many isotopes of selenium are there. So if you guys look at the graph, how many bars do you guys see? 5. So how many isotopes are there? 5. That's it. So there's 5 isotopes, and we know that because there are 5 lines. Okay, so the number of lines tells you how many different isotopes there are. You got selenium 74, 76, 77, 78, and 80. And then 2.5 just also asks you, which one is the most abundant? Which one is there the most of? Yeah, 80. How do you guys know that?
it's not as powerful.
Biggest bar, right? So that's the most. Okay, so that means selenium 80 is going to be the most abundant. Okay. So a lot of times when you get these mass specs, you don't, a lot of times it's going to be kind of hard because if you take a look, right? Let's say, for example, selenium 74. You just know it's under 10%, right? You can even estimate it as under 5%. I would say maybe even less than 2.5%, right? You don't need to be exact with your numbers. If they ask you for like, hey, what percentage is selenium 74? You can just estimate it. As long as you're giving something a reasonable answer, you should be good. And a way to find a reasonable answer is, hey, it's less than 10. Half of 10 is 5. It's less than 5. So maybe around half of that, around 2.5. If you say like 3%, that should be fine as well. Okay. So just a heads up about that. You don't need to be super accurate with your estimations. Okay, let's go to 2.6. 2.6 is asking how many neutrons does the most abundant isotope of selenium have? So if you guys take a look at selenium 80, which you guys said is the most abundant, and I'll give you guys a minute. I want you guys to calculate how many neutrons does selenium 80 have. So take a minute to do that. Jot it down on your paper. We'll go over it, and then we'll do the last problem for today. Oh, gosh. guys were able to find on the periodic table that selenium, let's scoot over a little. Selenium has 34 protons. So if the most abundant isotope is selenium 80, all you have to do on the periodic, or not the periodic, your calculator is just do 80 minus 34, and you should get a total of 46 neutrons. Okay. Any questions on that? It's just mass number. Okay, so I'm gonna have you guys do a problem where you create your own mass spec. Okay, and again, it does not have to be pretty. You'll see that mine is very ugly, but it gets the job done. Okay, so what we're gonna do is we're gonna set up the X and Y axis first. Okay, so we're gonna make a little graph. Oh, going bad already. Okay, the bottom of the graph is the X axis is going to be the mass number. Yeah. Oh, this right here, sorry, it's 85. You got rubidium 85, and then you got rubidium 87. Sorry about that. Okay. So the bottom right here is the mass number, or you can write AMU, whatever you're most comfortable with. And then on the y-axis, this is going to be the percent abundance. Okay. So far, so good? Okay. So from here, what we're going to do is we're going to draw our lines. And luckily for us, we only need to do two. We got rubidium 85 and we got rubidium 87. So let's start with 85. So what we're going to do is we're going to start by just labeling 85 right here, just to show that we're talking about rubidium 85. And this is going to be 72.2%. So I'm just going to draw kind of a tall line, okay? 72.2. You guys notice I can't even connect the lines together. That's how bad at drawing I am. Okay, now this is optional, but I'm gonna do it just to flex a little. 86 and then 87, just to show I know what number is between the two. Okay. And then lastly, we have rubidium 87, which is about 28% of the relative abundance. Now, this is the important part. You have to make the height reasonable. Again, it doesn't have to be exact, so don't pull out a ruler and start measuring like the exact ratio, right? As long as you're somewhat accurate, you're good. So 27, 28 is about a third, right, of 72. It's about 75, 25. That's about the ratio. So as long as your height is about a third, right, you're good. Okay. And if you really want to label it, you can 27.8. That's it. That's your mass spectra. If you wanted to get fancy and make it those blocks, you can, but you don't have to. I just do lines because I can't draw. So that's going to be mass spectra. So say you learned how to read and create your own. It won't get much more difficult than that. The only way it'll get more difficult if there's more lines. But that's pretty much it. Any questions? All righty.